Alright, this is the Unit 11 test review over area. This unit's going to be really important that you identify your formulas for every problem, but the first 4 problems are just definitions that you're going to need to know. So I'm going to read through them and kind of draw a picture of what these would look like, but then you'll also have to match them up with the definitions. So an apothem, that's a segment that's drawn from the center of your polygon, and it's drawn to the midpoint of a side. Okay, so you have this, that is called your apothem. It goes from the center to the side. Okay, so if we look at these definitions, A says a perpendicular segment drawn from the center of a regular polygon to the midpoint of a side. That right there is our apothem. Area, that's going to be everything that's inside your shape. Okay, perimeter is around the outside, area is everything inside. So if you look at C, it says the number of square units contained in the interior of a figure. That's going to be our area. That's everything inside your figure. A radius, just like the radius of a circle, the radius of a polygon also starts in the center. And it's drawn from the center, though, to a vertex. So you've got these 3 vertices in this triangle. Those are called radii. So that would be D. And then a regular polygon, that's just a polygon that's both equiangular and equilateral. So you can see here we have an equilateral triangle. I could draw a square. Okay, so that would be considered to be a regular polygon because they have all the same sides. I could draw a hexagon with all the same sides. It has all the same sides and all the same angles. It's considered to be a regular polygon. Alright, number 5. Compute the perimeter of the rectangle shown. Hint, you're going to have to use Pythagorean theorem here so that you can find the side. So first of all, for perimeter, I'm going to go ahead and write the formula for that. And we should all know that the formula is just add up all your sides. And it doesn't actually have the perimeter formula on the formula chart. That's just something you're going to need to know. But the formula for that is 2L plus 2W equals perimeter. You're adding your lengths and you're adding your widths. It's just here in this instance, we only have one side. So we only know the width, we don't know the length. So we have to do Pythagorean theorem to find that. So I'm just going to call that x. So I would have 15 squared plus x squared equals 25 squared. Okay, 15 squared is 225. Plus x squared equals 25 squared is 625. So here I'm going to subtract 225. So I have x squared equals 400. And if I want to remove that squared, I take the square root. And so this side is going to be 20. So now if I want to do 2 times my length, 2 times 20 and 2 times 15, that would be 40 plus 30, or you can just write them all in and add them all up, but you would get a perimeter of 70. Alright, number 6. Describe how to find the area of a square with a perimeter of 40. Okay, so think about, this is going to be really crucial that you draw a picture here. Okay, so think about, describe how you would find the area of a square with a perimeter of 40. Okay, if the perimeter of this all the way around was 40, that means every side is going to be 10 because I need to divide by 4 to get how many sides there are. Okay, and then the formula for the area of a square is side squared. And so what we would now do is do 10 squared, and so it would be 100. So this just asks what would be the process. So first I would have to divide the 40 by 4, and then I would have to square the number. so that would be B. Number 7, compute the area of the rhombus. Okay, so this is a parallelogram, and so my formula for this is going to be base times height.
Right.
Okay, so actually here we will use, not formula for a parallelogram. If you look at your formula chart, it's going to say area of a rhombus or kite. So the formula that you're going to use is area equals D1 D2 over 2. Okay, so here I'm going to come over here and write these in. So AE is 4, AD is 5. These two pieces are equal. So if that's 5, so is this, and that's 4.
AD is 5.
Okay, so I just wrote that 5 in the wrong spot, so I'm just going to start this over. So area equals D1 D2 over 2, and AE is 4. That means EC is also 4. And then AD is 5. That means BC is also 5. So here I need my two diagonals. I already know one diagonal here is going to be 8, but I need to find the other one, which means I need to do Pythagorean theorem to find this missing piece. This is a triple, so I could already look at that and know it's 3, 4, 5. But if I did Pythagorean theorem, I would do x squared plus 4 squared equals 5 squared. So x squared plus 16 equals 25. If you subtract the 16, you get x squared equals 9. And take the square root, and so x would be 3. So that little piece would be 3, and so would be E. So one of my diagonals is 8. The other diagonal is 6. So now I'm going to do diagonal 1, which is 8, times diagonal 2, which is 6, and divided by 2. 8 times 6 is 48, divided by 2 is 24, which is A. All right, number 8, so find the area. So you first need to identify what shape this is, and this is a trapezoid. So area of a trapezoid formula is height times base 1 plus base 2 all over 2. Okay, so I'm going to have area equals the height. Here is my height, 7. I'm going to add my bases together, so 10 plus 13 and divided by 2. So I'm going to go to my calculator, and I'm going to do 7 times 10 plus 13. I'm going to get that answer, and I'm going to divide it by 2. So the area of this is 80.5. Alright, number 9, determine the area of the regular polygon with the given side and radius lengths. Okay, so area of a regular polygon, that's going to be 1/2 AP, or I like to use AP over 2. That's apothem times perimeter over 2. So I'm going to see what we have here. I do not have the apothem. That's this little piece here. I can find the perimeter pretty quickly. So each side is 10. There's 6 sides. So my perimeter is 60. So I need to do AP over 2. I don't know A, but I do know the perimeter is 60. And divided by 2. And so now I just need to find what that side is. Okay. This right here, you can see there's even a 60 put in there. It's a 30, 60, 90 triangle, which means where the 10 is right now, that's my 2x side. The short leg at the bottom is the x, and that apothem we're trying to get is my x root 3. Okay, so if 2x is equal to 10, that means the short side is going to be 5, which means that long side is going to be 5 root 3. So that is now my apothem that I'm going to plug in to the formula. So if I do 5 times 60, divided by 2. 5 times 60 is 300. Divided by 2 is 150. So it would be 150 square root of 3. I'm just going to double check that. My calculator. 5 times 60 divided by 2. And then you throw that square root of 3 back on. Number 10, calculate the area of the kite. So I'm going to look over here, and well, first I'm going to write the formula. So the formula for area of a kite is going to be d1 times d2 over 2. So I can see over here, I already know one diagonal, 3 plus 10, and that's 13. I just need the other diagonal, okay, but I can see this little piece is 5, and I know those two pieces are equal, so the other side is also 5. So my other diagonal is 10. So I'm going to do 13 times 10 divided by 2. So 13 times 10 divided by 2, and you get 65. Number 11, find the area of the figure bounded by the lines. Okay, the line you can't see as well here is this x equals 0, so I'm just going to draw that one in. The other two are drawn in for you. This one probably is 2, you just can't see it. Okay, the shape that was created here was this triangle, and that's what it's wanting us to get the area of. So I'm going to count across the top, 1, 2, 3, 4, 5, 6, and along the side, if I count, it is also 6. So the formula for area of a triangle is base times height over 2. So here my base is 6, my height is 6, and I'm going to divide it by 2. So 6 times 6 is 36, divided by 2 is 18. Number 12, find the exact length of arc B. Okay, so this is arc length. This is actually a review problem from last unit. We are not getting the area of the sector here. We are just getting a piece of the circumference, a piece of the arc. Okay, so the formula for this is degrees over 360 times 2 pi r. So I'm going to do degrees, which is 130, over 360 times 2 pi, then my radius is 9. Okay, I'm going to leave, since it says exact, I'm going to leave the pi in here, but I'm going to do all the other calculations. So I'm going to go to my calculator, and I'm going to do in parentheses 130 over 360 times that 9, and I have 3.25, and then I still have the pi. And that keeps it as exact as possible. Number 13. Now here, we're going to find the area of the sector. So on the last one, it's like we found a piece of the perimeter. Here we're going to find a piece of the area. So sector area, the formula chart is going to say degrees over 360 times pi r squared this time, because we're talking about area. Okay, so I'm going to do the degrees. I can see this right angle right here, so it's 90 degrees. So 90 over 360 times pi, and then 3 squared. Okay, 3 squared is 9. In here it says that we're going to round. I'm going to still just do all the calculations without the pi first, and then I'm going to throw the pi back on just to make sure I get it right. Okay, so I'm going to do 90 over 360 times 9, and then I could have already put the pi if I wanted to. I just did it. So now I'm going to do times pi, and I get about 7.1. Okay, so yeah, so that comes out to be 7.1, so that is C. Now something I just realized on the last problem, because when I typed this one in, I realized I I felt like I just typed the exact same thing in. I think on this last problem, I forgot to do the times 2. I just did times 9. So it's not 3.25, it comes out to be 6.55. Just forgot to type the 2 in the calculator. Alright, number 14. Tammy drew a floor plan for her kitchen as shown. Which expression represents the area of Tammy's kitchen floor in square units? Hint, you can double distribute. We also call that foiling. And so here, area of a rectangle is base times height, or you can think length times width. So I'm going to do 2x plus 5 times 2x plus 1. And I'm going to use the process of foiling, which is double distributing. It's like I'm taking this 2x and I'm distributing it twice, and then I'm going to take the 5 and distribute it twice. But 2x times 2x is 4x squared. 2x times 1 is 2x. The inside, 5 times 2x is 10x, and 5 times 1 is 5. I'm going to look for any like terms. I have like terms right here in the middle. So 4x squared, that's going to be plus 12x, and then plus 5. So 4x squared plus 12x plus 5. Number 15, if the dimensions of a rectangle are doubled, which of the following best describes an effect on the rectangle? Okay, and if you look at the answer choices, it's talking about area. Okay, and what we saw is that the trend for dimensions changing is that whatever happens to the dimensions, so here they're being doubled, if it's asking about area and I square that, that's going to be the effect on my area. Just think about area as units squared. So here I want to take what happened to the units and I want to square it. Okay, so 2 squared is 4, which means the new area will be 4 times as large as the original. Number 16, determine the exact area of the 30, 60, 90 triangle. Okay, so the formula for our area of a triangle is base times height over 2. Okay, so let's see what we have here. We have base, which is 4 square root of 3, and we have height of 4. So I'm going to have base, which is 4 square root of 3, times height, which is 4, over 2. 4 times 4 is 16, divided by 2 is 8. So I should have 8 square root of 3. Number 17, 2 rectangles are similar. The ratio of the length of the larger rectangle to the length of the smaller rectangle is 3 to 1. Which of the following statements is true? So A says the area of the smaller rectangle is the area of the larger rectangle. Okay, well that doesn't really make sense. B says the perimeter of the smaller rectangle is the perimeter of the larger rectangle. Again, that doesn't make sense if dimensions are changing. C, the area of the larger rectangle is 9 times the area of the smaller rectangle. That is the one that is true. Because again, you take what's happening to the dimensions, so 3 to 1. Since we're talking about area, you're going to square that. So it ends up being 9 to 1. And then number 18, the scale factor of 2 similar polygons is 2 to 3. The perimeter of the larger polygon is 180 centimeters. What is the perimeter of the smaller polygon? Okay, so first of all, we're going to use that scale factor. And since we are talking about perimeter, our scale factor for perimeter is going to be the same as the scale factor of the dimension. Okay, so our scale factor here is 2 to 3. Okay, obviously the 2 goes with the smaller polygon and the 3 goes with the larger. And what this is saying is that the perimeter of the larger polygon is 180. So I'm going to put that 180 under where I have my large one. And then we're trying to find the area of the smaller. And what we have here is we've set up a proportion. Okay, there's another way of doing this. You could probably figure this out without setting a proportion. Really, you're working through it like a proportion in your head. But this is how you would set it up algebraically. So I would have 3x equals 180 times 2 is 360. And divide by 3, and you get 140.